Hello, my name is Rob Higurita, and I'm a Principal Technical Account Manager at AWS, and I'm based out of Austin, Texas. Welcome to AWS Supports You, where we share best practices and troubleshooting tips from AWS Support. Here at AWS Support, we practically help you optimize performance, lower cost, and innovate on the AWS cloud. Joining me today is Clint and Mike from AWS Support. Can you give us a quick introduction, Clint, and then Mike?
Yeah, hey Rob, and hey everyone. Thanks for taking a few minutes out of your day to join the stream. My name is Clint Wyckoff, and I'm an enterprise support manager based in Pittsburgh, Pennsylvania. So I lead a team of technical account managers and basically focus on customer objectives in helping you in your journey on the cloud.
Hey, I'm Mike Wells. I'm a technical account manager based out of Boulder, Colorado, where it's snowing heavily right now. I enjoy supporting customers from an operations and cost optimization standpoint. And today I'm going to dig in a little bit on API gateway and caching. But first, I'm going to let Clint and Rob answer a couple of questions. Glad to be here.
Great, thanks for the intro, both of you. And so today we'll be answering some of your questions you have posted on repost.aws. Specifically today, we'll be covering questions surrounding serverless. But before we get started, a quick note to the attendees online. Please feel free to use the chat window on the right-hand side of your screen to let us know where you're joining us from today, and then share your thoughts and questions throughout the episode. We do really look forward to hearing from you all throughout today's episode. And additionally, if you'd like to see us dive deep into a specific topic, head over to repost.aws and submit your questions there. It may just be a featured episode in the future on AWS Supports You. So with all the introductions, I'm going to turn it over to you, Clint, to answer our first question for today.
Fantastic. Thanks, Rob. So as we had said there a little bit earlier, we're going to be focusing on some questions that were posted over on the repost.aws. It's much like a forums where you can go and ask questions, and the community will chime in and answer them where appropriate. So the first question that we're going to be focusing on here is, in the first topic specifically, is in the realm of serverless. So serverless is one of the most popular topics over on Repost, and there was a few lingering outstanding questions that we have decided to take on. So the first one here, focusing around network load balancers and how they do not forward traffic along to AWS Fargate, which is a component of ECS, Elastic Container Service. So we're going to be focusing there first. If we zoom along here, we sort of take a step back for a moment and understand why serverless is such a popular topic over on Repost. And there has really been, over the last several years in the IT world, there has been a paradigm shift in running physical machines on premises. And AWS does have a solution there where we can help reduce latency and pull the compute power as close to the application as possible with outposts. And that sort of ramps up the scale there, where the level of abstraction goes away from the services and into to Lambda, and all the way up to the serverless landscape here, where you focus on the actual business logic and writing code, and you're not worrying about managing servers and things like that under the hood, right? So basically, what we can do here with Lambda or Fargate, for example, it's a serverless offering where you don't have to worry about managing any of the servers or anything like that. As I mentioned there briefly, the paradigm shift from managing servers and going more towards a serverless approach, which allows you to, or business, focus on the business logic and writing the code, in Python, for example, or Node.js, or PHP, for example, whichever the development team is most familiar with, right? But as that operational model shifts, so does the level of responsibility that you as a customer own, right? So at the bottom here, you have EC2, which is basically virtual machines in the clouds. You have instances where you need to worry about managing patching, sizing, making sure that it's kept up to date, the operating system, creating custom AMIs, worry about virus, antivirus, all that type of stuff that goes with managing virtual machines, right? As you sort of shift up the scale there, you get into the realm of managed services like ECS and EKS, where you still own some level of the responsibility with versions that are being run. For example, with EKS or Elastic Kubernetes Service, which version of Kubernetes do you want to be running? All the way up to Fargate, which is a serverless offering It is a containerized approach where you containerize your application. You store that in a repository, ECR, for example, Elastic Container Repository, but it's serverless, meaning that auto scales. So once you write the code for your application, run that through Docker, containerize it, then you can publish it out to your container registry and consume it through Fargate. And then to take it one step further, where literally the only thing you need to do is worry about writing code, is Lambda. So that's the serverless event-driven architecture that Rob's actually going to be talking about here in a few minutes. So a little quick sort of update on Fargate specifically. This is completely 100% managed by AWS. So there's no specific EC2 instances or anything that you as a customer need to worry about deploying or patching. It is 100% serverless, which the nice part of that is when you choose the Fargate launch type through the ECS service, it'll auto scale out and in back again. But then the nice thing is it's fully integrated with many of the existing AWS services. So as you'll see, as I bring up the demo here in a minute, it works directly with application load balancers, ALBs, at the layer 7 level, as well as layer 4 network load balancers as well, which really focuses on, your individual use case and what you're looking for there. So what I put together here is just a quick diagram that illustrates sort of what a typical environment would look like, where you have the AWS environment, AZ1, AZ2, and how you would route traffic across those. So whenever you create your Fargate environment, your Fargate cluster, basically, here you have task definitions, and as part of that setup and configuration, you choose how many subnets, VPC subnets, you want that to span across, which is the different availability zones. So you want to definitely take advantage of a high availability component there so that you can route traffic accordingly, right? So let's switch over to the demo here. And first, you will see here that I have my test cluster. And inside of my test Fargate cluster that I've deployed here, I have two services, right? The first one that we're going to take a look at here is focused around the network load balancer as well as the application load balancer. So each one of those has a separate configuration. One has an ALB that's fronting it, and one has a network load balancer that is fronting it, just to show you the different behavior and what that would look like. So here you can see the individual tasks that we have running. Monitoring is very important. So the overall health in the environment, so these are CloudWatch metrics inside of the Fargate cluster. It utilizes ECS agent to monitor CPU and memory utilization of the given tasks and the services underneath there. As we switch over to the networking tab here, you can see that it does directly integrate with the load balancer. So here we can see that we have my test load balancer, and we are going to open the EC2 console up to take a look at our load balancer as well as the target group. So all the Fargate tasks, which are the individual worker nodes that are going to be responding to our web request here in a second. These are behind the load balancer in the target group. And we can see here that it is of the application, or the load balancer is an application load balancer. So it operates at the layer 7 level as opposed to a network load balancer, which operates layer 4. So keep this moving along here, and we'll open the FQDN, the fully qualified DNS name of my web page, and we'll just do a couple of quick refreshes here. And the thing that I do want to call out here is the IPv4 address of the target instance. So down here, 172.31.8450.137, right? You have a different node or task responding to each individual request, right? So it's different every single time. And if we take a look here and double click into the actual load balancer, it's utilizing the round robin load balancing algorithm, as well as stickiness is disabled. So each one of those individual requests that are coming through, they're being routed to a different task, okay? Whereas the original question that the user had asked was around network load balancer. So let's take a look at what that looks like here. So if we now pivot back our view within the Fargate console over to our ECS cluster that we built that has a network load balancer fronting in. Here's, we'll take a second, switch over. Here in this individual group, we have 5 tasks, which are going to get registered behind the network load balancer. In the target group there, just taking a look here at the configuration, you can see that they are a Fargate launch type. And the other thing that I would call out here is the CPU and memory that does get allocated. So this is defined in the task definition JSON document that you would write. Taking a look here at the network, as I mentioned earlier, just want to call out here on the left-hand side that you do have all of the subnets. So in US East 1, I've deployed this across 6 AZs to make it highly available. Keep this moving along. And then we'll switch over to the EC2 console so we can grab our fully qualified DNS name. Now, whenever we do that same refresh, whereas before with the application load balancer, we have each one of the individual targets was responding, right? This with TCP connection, you're going to have the same target respond for the duration of that connection request as long as it's out there. So each one of these refreshes that I'm doing, the same target behind my network load balancer is going to continually respond. So even though I have new healthy tasks getting launched as part of my auto scaling group, the individual connections, they're going to still be routed to the same task as it was previously, as long as through the duration of that request. So just flipping over here to the documentation, and this is basically called out here in the documentation as part of the network load balancer behavior. So typically, if you go through this, and if we look at questions that we normally get from folks in the field is around, hey, how do you monitor? What does monitoring look like from a Fargate or ECS perspective? So I do want to take a minute here and take a look at that. And within the actual UI and console, I touched on this a second ago, was the native CloudWatch capability within the Fargate UI, right? So here you can see CPU and memory statistics, very high level sort of information. Well, if we do have a capability within CloudWatch called CloudWatch Container Insights. So what this does is it can be enabled for new clusters. I'll show you how to set that up here in a second, but it also can be enabled for existing ECS clusters that you've deployed. So both of those options are able to be leveraged via a CLI command here. So the first one on the top of the screen, we'll go ahead and configure this for anything new that you create in the future. But the second AWS CLI command that's on the screen will go ahead and it will enable the CloudWatch Container Insights for any existing cluster. So what we're going to do here is we're going to leverage AWS Cloud Shell, which is a native CLI capability that we have that'll pop a browser tab here and allow you to interact directly with your AWS account and not have to worry about like Visual Studio Code configuration or any local terminal setup. So I am utilizing Cloud Shell here. And I've basically just run that single command, and I've now got CloudWatch Container Insights enabled, right? So what does this look like for any new clusters that we create or deploy in the future? Fantastic question you should ask. So we will pivot back over here to the Fargate UI. Within the settings area, you are able to configure the CloudWatch Container Insights for any future instances or clusters that do get deployed. It's just a checkbox. So any of the new clusters that would come online from here moving forward would have CloudWatch Container Insights enabled. So if we pivot the view and switch the services along the top, so you would just type in CloudWatch along the top to open the CloudWatch console. And down on the bottom left here under Insights, there's a Container Insights option. The first thing that we will do here is switch it over to performance metrics. A second here. Go down to performance metrics. And then within the performance metrics here, we're able to see the different services that we have available to us. Choose ECS. And there's a list of ECS metrics that you can monitor for: clusters, instances, services, tasks, for example. And then on the right-hand side, you see the test cluster that I deployed and all of the different metrics and CPU utilization, memory, network bandwidth being utilized bytes per second, network transmit, network receive, tasks, right? So there's a lot of really good insights. If we look at the individual tasks, we can keep track of how things are scaling. And then down on the bottom, there is individual task and container performance insights that you can get at an individual task level. And since this was utilizing Amazon Linux 2, it is running the HTTPD container name. That is a default container that we do have available for running test POCs and things like that. So that basically wraps up what we had shared for the session today. So basically, to wrap it up and bring it full circle back to the question that we were asked, we believe that what the user was seeing was, in fact, an expected behavior and how the tasks were being forwarded through the network load balancer. One sort of caveat that I would challenge is, is network load balancer NLB the appropriate type of load balancer, or should they be using an application load balancer that provides more intelligence, being able to operate HTTP, HTTPS level, as opposed to the network load balancer, which is layer 4 and just standard TCP connection. So that wraps that section up for today. And Rob, did we have any questions from the crew online come in?
Hey, Clint, thanks for all that information there on NLB and Fargate. So we did have a question that came in from the audience from JibJab06. JibJab06 was wondering, does CloudWatch Container Insights also work for ECS clusters that aren't Fargate or even on EKS as well?
Yes. So the answer to the question is yes. So with ECS, you just need to make sure that the ECS agent is present. And then it also works with EKS also. Yes, that is 100% supported configuration.
Great. Thanks, Glenn. Appreciate that. So that was the only question that we had come in so far from the audience. So again, if you do have additional questions, please feel free to put them into the chat and we'll get them answered here today throughout the episode.
Mike, I believe you are going to be next, and you had some API gateway topics that you wanted to talk about today.
Yeah, absolutely. So we had a question come in from Repost about how the cache encryption mechanism works for API gateway. I'm going to jump in and talk a little bit about, kind of lay some groundwork about what API gateway is and what you might need it for first. So first of all, let's talk about what an API is. And just breaking down the question to give some background to those who might not be familiar. An API is a way for developers to interact with data from another source or to another source. For instance, sites like Facebook or Twitter might have an API to be able to interface with the social network in that way. Just basically a catalog of functions to be able to interact with a product or service. And what we have at AWS to support you with this is Amazon API Gateway. And an API kind of acts as a front door for applications to access data or business logic or functionality from your backend services. And using API Gateway, you can create RESTful APIs and WebSocket APIs and enable real-time two-way communication for applications. An API Gateway supports containerized and serverless workloads as well as web applications. API Gateway handles all the tasks involved in accepting and processing up to hundreds and thousands of concurrent API calls, including like traffic management, cross-origin resource sharing, authorization, access control, throttling, monitoring, API version management. And API Gateway also has no minimum fees for startup costs. And you only pay for API calls you receive and the amount of data transferred out. And with the API Gateway tiered pricing model, you can reduce your cost as API usage scales. Next up, I have sort of a typical API structure, how an API might look. So an API is sort of a front door to all the different things, all the different distributed systems you might have in the background. So in this case, we have even services that come in through all these websites or mobile clients, come in through HTTPS, run through a CloudFront distribution, and then hit the API gateway. And then from the API gateway, that could fan out into Lambda functions, public endpoints on Amazon EC2. It could even go back to your on-premise data center to pull data from there. And in doing this, some of these operations are quite costly as they have a bunch of hops to go through behind API gateway to be able to reach into wherever they're accessing the data or putting the data to. So we created something called API Gateway Cache. And caching is just, for those who don't know, caching is just a way to be able to store data as calls come in, to be able to have that data handy for if the same call comes again, to be able to respond back with the same information. So this caching mechanism that AWS provides with API Gateway is when this cache is enabled, all the Git methods have cache enabled by default, and you can override and enable cache on individual methods and specify parameters to be included in the cache key. But by default, the cache key is built up of a namespace, which is a customer configurable field that is usually the resource ID. Also the HTTP method, so this would be either get or put or post, and cache key parameters, which is like a combination of the method and integration header, query string, path parameter, and a version number of the API. So what this results in is whenever a customer or whomever reaches into your API gateway and makes a call to be able to get some particular piece of data, this key is built to be able to provide that data directly back to the caller. So it speeds up response time to your customer, so it looks best to your customer to be able to have these quick responses, and also it eliminates as much traffic on your system. So as I mentioned, if you had data that was stored in your on-prem data center, then this data wouldn't have to be fetched all the way through all those hops to get back there. So this cache is also HIPAA compliant. So these data that are stored in here are compliant with to allow you to store policyholder information. The next, I wanted to talk about how the caching actually works. So you can override single stage cache level settings by enabling or disabling cache for a specific method, or you can increase or decrease TTL periods, time to live periods, for each of these cache things by turning encryption on or off for cache responses. So API Gateway caching is encrypted or is implemented by using client-side encryption with KMS. And when encryption is enabled, all the cache data are encrypted using AES 256 keys from KMS before being passed on to the caching service. A new KMS key is received every 15 minutes to encrypt the data prior to storing it. So as you can see, there's a workflow that goes through how cache encryption works. Request comes in from the customer. If it comes into the API gateway, it looks, if it's a cache hit, it goes and gets the result with the cache key, decrypts that data, sends the decrypted data back to the customer. And if it's a cache miss, it goes in, encrypts that data with the cache key that I mentioned earlier, encrypts that data, stores it in the cache, and then returns that data back to the customer. So that's how encryption works with API Gateway. Any questions from the field about this?
Hey, Mike. Thanks for covering that, and thanks everyone for bearing with the technical difficulties I had. We're kind of dropped off the face of the planet for a second there. So no current questions that came in from the audience. So please, if you do have questions, feel free to post them here in the chat, and we'll be happy to get to those. So.
While we Rob, while we do wait for questions, I do have one. Are the cache keys themselves, like, are they encrypted, or how does that work to keep that secure?
Yeah, that's a great question. The cache keys are not encrypted, just because these are just a combination of the data that have come in from outside. This is just if we were to encrypt it, we wouldn't be able to get the cache out with the key. So so the cache keys are not encrypted. Yeah.
Gotcha.
So again, if you do have additional questions, please feel free to put them into the chat, and we'll get them answered here today throughout the episode. But I'm going to take over for Clint and cover our next question that we had come in on repost, which was about using some Lambda for automation. So we had a question that was submitted for Lambda automation here. And looking at it, I'm working on some POCs to migrate applications from on-premise to AWS. They wanted to know, what can I automate using Lambda if I deploy and manage workloads from, say, an Amazon EKS cluster, resources like ELBs, ECR, RDS, just kind of thinking of some different use cases. So as we're kind of looking at going through it, overall, really kind of an ambiguous question of things. So I'm going to cover a little bit on AWS Lambda and serverless in general. And then also kind of talk a little bit about how you can use Lambda specifically in a EKS scenario, on how you can update and do things here. So we will get back in and I'll walk through and show in the actual presentation a little bit about, on AWS Lambda and how it's been around for years. It has thousands of customers that are implementing and using it. And that has kind of led to trillions of Lambda's executions per month, right? So as we get going through here, we're going to talk a lot about, automating tasks and doing different things here, right? And in the iterations of customers adopting AWS Lambda and having these different iterations, it's led to, some different design patterns on ways that people bring workloads to AWS. So I want to kind of touch on this because it will help a little bit on the overall, automating those tasks with EKS or EC2, EBS, RDS, and a lot of different things. So one main reason why you can adopt and use, and why this person's kind of looking to add this, is reduce the amount of do-it-yourself that you have to do within your AWS environment. So where you may be able to retire things that you have to manually log into the console to do, react to EC2 instances that high CPU, instead you could have automated tasks do those and move towards really using things that are available to you to free up time to actually develop your application. With AWS support, a lot of things we try and help our customers with as TAMs is to be operationally efficient and deliver. And so when you maybe migrate your environment into AWS, it may have started as a lift and shift, and you may want to modernize that, right? Whether you're looking at re-platforming it or refactoring it, layering in these automation tasks and being able to remove the overall manual interaction is, kind of key. And so as we go through looking at this, we move from people doing things in your environment to services and automation basically doing things in your environment for you. And we do that by having a lot of small pieces loosely joined together, where we kind of have a decoupled architecture where we can align what we call an event-driven setup instead of you having to be people-driven on it, right? So we have a number of different AWS services. Clint touched on ECS Fargate, which is a serverless containers orchestration platform that we have. We've got other ones that you may not think as serverless, but things like S3, SQS, DynamoDB, the simple workflows, a lot of different items. And these will allow you to contribute to this event-driven architecture, so you can use events to automate things in your account. So instead of having to create, say, new snapshots of things in your environment and go into the console and do that, or have somebody actually type a command that does this and install tools locally on your machine, you can have it kind of automate in fashion for you. And so that's what we really want to kind of cover today, as we're answering the question towards the EKS, automated task, is leveraging IT automation to respond to infrastructure events in your AWS account. So again, responding to a disruption, you can leverage AWS Lambda to do so using things like Event Bridge, where an event may trigger inside of your account that tells Lambda to do something for you. This could be, I had a use case for a customer. This looks into autoscaling as well with EC2. So within autoscaling in EC2, we have instance lifecycles, and the lifecycle components essentially when a instance transitions from starting to being available to actually use for you. You may leverage a lifecycle hook to implement something. You may use a lifecycle hook when an instance terminates as well. So in my customer's use case, they had a bunch of Windows servers that they use, and they use the seamless AD domain join feature within EC2 to get the instances into Active Directory. But every time that they had autoscaling events where an EC2 instance would be removed, they had to go in and manually clean up the domain object from Active Directory, because if you just shut off an instance or shut off a server, even an Active Directory outside of AWS, you will just be left with a computer object that is there in the background. And you may kind of have thousands of those in the long run, and you may not want to keep those. So before using IT automation and events to drive this, they had to set up a script essentially that would monitor for last password change on their Windows servers, and it would move it to a specific organizational unit in their Active Directory to disable it. They'd have to verify that, have somebody actually go back out and then clean up those servers that had been out there for, say, 90 days or 180 days without, being changed after that. And it really required time in order to be able to do this. By leveraging lifecycle hooks and Lambdas into that, instead, they can actually have it feed the instance ID to the Lambda and say, hey, run this PowerShell command on that using the remote connectivity to the instance to do a domain disjoin. And that way it would clean up the object for them. So you can use it to, help automate a number of different activities inside of your AWS account. We have a bunch of additional services for security like Guard Duty and Security Hub. There's automatic remediation actions that you can set up that are, again, event-driven from, say, a finding that generates in Guard Duty, allowing you to, again, have a Lambda function run that will take an action to, say, remove a rule from a security group or add a rule to a security group, or even just change a security group on an EC2 instance to help you protect your environment quicker without having to rely on somebody logging into your AWS account to do so. So a lot of additional items that you can kind of implement and use there as well. Today specifically, though, to get back to how you can use this with EKS and kind of automating some of the tasks that you might have in EKS, we're going to talk just about one specific use case, and we'll provide a couple links into the chat as well for how this actually works. And we'll take a look here in just a second at a blog article that we have out there that will walk you through how you can implement using Lambda with your EKS cluster to take care of updates and stuff. So, and so main thing, really just showing a little architectural diagram here, and you can review the blog online with this. We want to be able to leverage Lambda here to remove, and this goes back to the whole IT automation, removing do-it-yourself, right? As we get into this, it's basically being able to leverage a Lambda in order to be able to update your EKS clusters for you. Traditionally, as we would be looking at a administration of an EKS cluster or Kubernetes in general, you'll use tools like EKSCTL or kubectl in order to update or make configuration changes to your Elastic Kubernetes Services clusters right within AWS. And so with that, you have to then also give permissions to each individual user that's going to be implementing these changes, hope that they don't make any misconfigurations within the environment doing that, and kind of, have to add that additional trust as people come into the company, leave a company in order to administer this. So by leveraging AWS Lambda in the blog, if you take a look at that one, it's going to help you to be able to set up and implement a fashion where you can remove the manual steps of creating a new user, creating a configuration for them, having them install tools like kubectl and EKSCTL locally on their machine. And instead, what it's going to be able to do is be able to leverage a versioned container that's going to live in our Elastic Container Registry Service, or ECR, in AWS, where you're going to be able to keep a copy of that that's going to get used to run on your Lambda. So as you make a config map that you're going to want to use to update your Kubernetes clusters, instead of having to have your users install those tools locally, they can instead just invoke a Lambda function that's going to have that container running on it to make those updates and changes to your Kubernetes clusters for you. So this is going to free you up from having to administer users, create different IAM roles within your account for maybe each person, and instead have one central policy that you can govern and control that has access to your various EKS clusters as well, and help you just kind of reduce some of the overall administration steps that you're going to have in your environment. So we'll essentially just be able to have our JSON docs, keep those in a repository as well. That way you can keep versioning on those. So as we make a push for all of our customers, we like to have them do everything as infrastructure as code where possible. And again, that just helps you to remove, people going into the actual AWS console to make changes to your environment, freeing yourself from being able to have all those manual interactions that, as I mentioned before, having you do those that you normally do, and really move towards event-driven infrastructure as code and serverless where possible, so that you can free up your administration. So that covers kind of a recap of everything I wanted to cover in the overall items before we got into a little technical difficulties there. So stop there just to see if we have any questions from the audience. Bring back Mike and Clint as well.
Yeah, hey Rob, thanks for circling back on that, and welcome back to the face of the planet. It's good to have you here. So we did have a question come in, but it was unrelated to really the topic of the day being serverless. But I do think it is a very good question and valid question as users look to migrate, workloads and things of that nature to the cloud. So this one comes from Cloud Guru 2053, and they say, "Hi, thank you for very informative details. Quick unrelated question, as they say. What would be the best approach to DMZ migration?" And I think the best way to answer that is we have a vast array of services that can help you actually migrate the services or computers, virtual machines, databases, things of that nature running in your on-premises environment that can help you with that. But coming up with like a secure multi-account strategy and being able to segregate out, the environment that's DMZ specific, because that's chances are that's very, very critical sort of information, external facing. You want to make sure that you have a very small blast radius there. So I would recommend creating a separate AWS account to handle that information, and then, create peering or transit gateway connections to other accounts that it might need to connect to. I can throw a link to a multiple account strategy white paper that we have here into the chat. But Mike, Rob, is there any maybe alternate approaches or different thoughts that you might have on that topic?
Oh, yeah, I can add a little bit to that, right? You mentioned, multi-account strategy is good. As far as like if you're talking about primarily your web services or your front end, it kind of depends, right? If you want to move it over just as a straight, kind of re-platforming, taking it from on-premises into AWS, keep it all as EC2 instances, you can do that approach as well. Leverage things like NLBs, ALBs in order to really kind of sit on the public edge of your environment, and then have, a few different design consideration and changes potentially in AWS than maybe what you would do on-premise with your web services. So we definitely have a lot of resources. It's also a great question if you want to post it on repost.aws. We can, you'll definitely get some good answers there on migration strategies. We do, as Clint mentioned, we have application migration services. We've got what was previously branded as Cloud Endure for that, to help you be able to easily replicate your on-premises environments into AWS. We've got server migration tools, lots of additional assistant resources to move things to AWS.
Hopefully that helps. As they were saying here, as in lift and shift. So basically, there, if it's running as like a virtual machine on premises, you could utilize the server migration service to shift that over. But then any other ancillary services downstream that it connects to. So if you had a database or things of that nature, you're going to want to make sure that you replicate those or migrate those out to the cloud as well. Perfect. We will pause here for a minute or so. Gentlemen, did you have any closing comments for today while we see if any other questions come through?
Yeah, just to circle back to what I was talking about, overall, as we were talking on my section for using Lambda for EKS, as I touched on before, just overall event-driven makes life easier, I think, for IT administrators. So posted a couple different links to different blogs and stuff today to take a look at, as well as some different resources for getting started with leveraging IT automation in general with Lambda. But there's a lot of additional resources. Definitely take a look at those. Mike, anything you wanted to add as well?
No, I don't think so.
All right.
Yeah. The follow-up question from Cloud Guru 2053, can we use Cloud Endure? Well, it's no longer known as Cloud Endure. They renamed the product to AWS Elastic Disaster Recovery. So you're looking for the correct service in the console or product documentation. Can we use that for DMZ services? And I think the important thing there is making sure that you read the product documentation and make sure you have like the correct ports open and communication from on-premises out to the cloud. That way you can establish connectivity and those jobs that you create, the tasks that you create, flow as expected.
Yeah, great point, Clint. All right. So yeah, we don't have any other questions. So everyone, today we looked at and answered some of your questions from AWS Repost, specifically focus on serverless technologies such as AWS Fargate, Lambda, and API Gateway. But if there are any questions that were not answered today, you can post your questions over there on repost.aws. to receive answers from our community of AWS experts and maybe have your question featured on a later show. Please email us any feedback to awssupportsyou@amazon.com. We want to hear from you. Let us know what else you'd like to see on the show. Be sure to join us on Monday, March 14th at 8 a.m. Pacific. We'll be talking about securing your quantum development environment with Amazon Bracket. Thanks for joining us at AWS Supports You, and happy cloud computing.